Okay, students, let's just go over the exterior angle theorem and our vocabulary. Exterior angle theorem, you need to have it memorized. You're guaranteed to see it on the decals. The exterior angle, obviously exterior means outside, so it's the only outside angle of the triangle, equals the sum, so equals the sum of the two opposite interior angles, also called opposite, not opposite, but remote interior angles. You need to know both words. So obviously I just subtract the 50 across and I get x equals 70. Real simple. Okay, let's go to, that's elementary level down there. Let's go to middle school level here, pre-algebra. Okay, so we have the exterior angle, 8 plus 6x equals the sum of the two remote interior angles. That's the geometry part. Now the rest is pre-algebra, 7th grade math, 8th grade math, 9th grade math. Okay, you've been doing it for 3 years at least. Move the smaller one over to the bigger side, so it always ends up being positive. Okay, 30 plus 2 is 32, minus the 8 across is 24. So x equals 12, pre-algebra. Okay, if you're struggling with that, you need to go back and learn pre-algebra. Okay, that's when you start doing that. All right, next page. Okay, these are all the same. Let's see if there's anything more complicated here. Okay, here's the difference down here is we aren't just finding x, now we're finding a particular angle, measure of angle S, this one right here. So we still have the exterior angle theorem, 140 equals the sum of the two remote interior angles. Okay, that's the only geometry part. The rest is pre-algebra. So we have 11x equals plus 8 minus 8 across 132. Now you have your times tables from 3rd grade and 4th grade. Divide by 11 and you get 12. So x equals 12. When I go back and read the question, it doesn't just want x, it wants the measure of angle S. So angle S is right here, 3x plus 4. So plug in the 12. 3 times 12 is 36 plus 4 is 40. So that's 40 degrees. Well, if I look right here, this linear pair, that also is 40 degrees. Okay, so that also then tells me that I have an isosceles triangle. Okay, so because I have base angles of 40 being equal. So for the converse of the isosceles triangle theorem, says the base angles are equal, then the opposite sides of them are equal. And now I have an isosceles triangle. Now, just to know, if I have a 40 there, 140 there, and I get the 40 here, well, now I could also use the triangle sum theorem and say all three of those angles add to 180 and solve it for x that way as well. But that only nicely worked simply just because you have a number out there. But if you have an algebraic expression, then you want to use the as 1718R. For example, the exterior angle is an algebraic expression, then we want to set it equal to the sum of the two remote interior angles or opposite interior angles. Okay, next page. This, we're finding blank missing angle measure, but we're going to add one thing in here. We're going to justify our steps along the way. So I'm trying to find this right here. Well, the first thing I have to find is this angle right here, but before I can find this angle, I have to find this angle right here. And how do I get that? I know these three angles add up to 180 by the triangle sum theorem. Okay, well then I know that 120 goes right across this 120 because of the vertical angle theorem. Vertical angles are congruent. Now I have two of the three angles in the triangle there, and I can use the triangle sum theorem again. And I have 120 plus 39 is 159 from 180 is 21 degrees, and that's why I have a 21 right there. But I've written down my justifications along the way. Let's look at the other example. Okay, I am trying to find this angle right here. Okay. Now, we did a lot more work by adding this stuff in over here, which I didn't need. Because I have this 155, this forms a linear pair right here, these two angles, so that means they're supplementary, which means they add to 180. 180 minus 155 is 25 degrees. So now I have 25 degrees. Oh, I did have to do it all. Okay, because I could, if I knew what this angle was, add those together and that would be that angle, but I don't know what it is, so I have to work my way backwards. In order to know what that angle is, I have to know what this angle right here is. But in order to know what this angle is, I have to first know what this angle is. But in order to know this angle, I have to first know this angle. So these two angles form a linear pair. That's why it's a linear pair theorem. 180 minus 115 is 65 degrees. Now I know that these three angles in this triangle add together to 180. So it makes this 30 degrees by the triangle sum theorem. Then these three angles, this right angle here plus the 30 is 120, plus the missing angle, which is 60, adds to 180 because it's a straight angle. Remember, we cannot call it a linear pair because there's not a pair. There's three of them. When there's three or more angles, adjacent angles together that form a line or create a line, then it's a straight angle theorem, which is 180 degrees. Now I do have these two remote interior angles or opposite interior angles, so I can go 60 plus 20 is 85 degrees. Okay, by the exterior angle theorem. Okay, so that's what you're doing for all of these. For example, vertical angle theorem, we'll do one more here. Vertical angle theorem right there, nice and easy. Here's vertical angle theorem. So vertical angle theorem. Now I have these two, which adds to 120, which makes this 6 degrees by the triangle sum theorem. Okay, then I have these three angles, meaning this last one right here is a straight angle. That's 180 degrees, and that is 139 from 180 is 41 degrees. So that makes this 41 degrees. Well, now I have the exterior angle theorem right here. That exterior angle equals the sum of the two remote interior angles, which is 109. So that makes it 109 using the exterior angle theorem. Okay, backside here. Looking at number 19 here, we have the exterior angle theorem again. The exterior angle equals the sum of the two remote interior angles. Solve for x there. Okay, I can use vertical angles, bring this across 80, bring this across vertical angle theorem 60. All three of those angles add to 180 by triangle sum theorem. Here I need to recognize I have 90 degrees right there, so 90 plus these two angles add to 180 degrees, the triangle sum theorem. Notice I use the same ones over and over in these here. Combine like terms, I get 2x plus 194 equals 180. Subtract the 194 across. 2x equals negative 14. And last set divided by 2, and you get x equals negative 7. Now, I am not technically done there because it says find the measure of angle A. A is right here. So I take that negative 7 and plug it in right there. Negative 7 plus 37 is 30 degrees for the measure of angle A. So that would be my final answer right there. Okay, and I believe that is it. Yes, it is. So you should be able to do every one of these problems. You got these examples here to use.